Hello, my name is Steve Quern. I'm continuing on my video with the IRONCLADS Ether Flyers warship design concepts. Basically, I'm doing this video series is inspired by USA President Donald Trump's Golden Fleet concept. However, I've done these warship designs, the warship designs and the fleet concepts prior since the 1980s as a high schooler when I studied military technology and military history, and when I was doing role-playing games and video games in the 2012-2016 time period. Also was doing computer games stuff, like Galactic Civilizations, so yeah. Within this video series, I have already talked about the basic unit measures for the. Let's get this out of here. So I'll just okay. I've already talked about the rock is in the way. There we go. Okay, so I have already talked about the basic measurement systems that the game system uses. I've talked about ship ranges. I've talked about naval warship types. I have to wear. I'm not wearing my glasses right now. And the civilian mission roles for the naval vessels, civilian naval vessel mission roles, and military vessel mission roles. So what I'm going to talk about now is more the ship design rules, the naval vessel ship design rules for the game system, IRONCLADS and Ether Flyers. You have within the ship design rules two major factors: mass, hull size. Hull size 1 is equal to 50 feet, and then mass 1. Okay, so that's here. Mass 1 is equal to 250 tons. Within the game system, you have 3 draft hull concepts. You have a shallow draft, shallow draft, you have medium draft, and you have deep draft. Within real-life warship, real-life naval vessel designs, your draft is actually measured in feet. And but within the game system, it's classified as shallow draft is for rivers, medium draft is shoals, and deep draft is oceans. So if you're in deep draft ship, you're going to run into shoals and medium draft, and your medium draft, you're going to run aground while running in rivers and stuff, on the shallow shorelines and shallow rivers. So the rules on that. Okay, so okay. I made a video earlier and I kind of wrecked the book now. I tried to do this video earlier and I separated the back end of this thing. I'm going to have to tape all that in there. Okay, let's see here. So, here's the rules for okay, here's the rules. I gotta put my eyesight on again. If the mass is more than twice the hull size, it is a deep draught ship. So a hull size 1 is 50 feet. Anything that's twice this hull size, anything that's greater than 2 a mass that's is more than hull size 2, mass 2 is a deep draught. So a mass 2 is 500 tons. So mass 3 or deeper is a deep draught ship. So anything that's more than 250 tons is a deep draught ship for on a hull size 1. If its mass is more than its hull size, but not twice as much, it's a medium draft ship. So anything, if it's a hull size 2, would be a medium draft ship. So actually, with the hull size 1, mass 2 would be a deep draught ship. This is more than its hull size, but not twice as much. It is a medium draught. So hull size 2, well, yeah. The house, okay, that'll be, let's see here, what's the math calculations here? For hull size, okay, for a ship's mass is its total tonnage divided by 250 tons. For example, HMS Trafalgar has a displacement of 12,930 tons. Thus, its mass is 50. Each row of boxes has 50 boxes. So the hip box is on the. This is how I lost the. I was looking at these ships here, and this came off. So you got a ship form with the box rows. There you go. 10, 20, 30, 40, 50, 60, 70, 89. So the maximum mass the game allows is 90. So you knock off 10, so 10, 20, okay, 10, 20, 30, 40, 50. And then these would be knocked off, or you go knock these off, and then once you take damage, you knock the rest of boxes off, and one row you loses one hull speed. One movement rating. You lose another movement rating, and when you get all 5 rows, you're sunk. And then there is a distinction between flooding damage and gun damage. There's a distinction between that. So flooding damage can be repaired. Gun damage are not repaired, or can be. I forget the rows on that. So yeah. 900. Okay. So let's do 12,930. Let's do the numbers here. That one. That one. Okay, so 250 tons divided by 12,930. That's 4. Nope, 5. 8. 6. Nope, 5. You're right. They said 50, so I said it's 5. Zero. 25. 10 plus 2 is 12. So you now have 430 to play with. And that's 1. Turn to 50, that's 4, 6, 30, that's 12 and 15, 14 and 17. That's 5. That's 50, and that's 2. Okay. Seven. Come on, behave. I can't write anymore. So that's 35. 14 plus 3 is 15. Wait, 14 plus 3 is 17. So you got 500. 50, you got 50, then 500, and that's 2. Ships with 2 tons have a parenthetical, whatever, parentheses mass, and their tonnage is divided by 50. A parenthetical mass number indicates the total number of hulls which can be taken on a ship before it sinks. So if you got a ship that has a parent hull of 50, then you don't, the bottom 4 are filled up, and then you only have 1, 2, 3, 4, 5 hulls to play with, and then the rest are knocked out. And then, yeah, then these would be knocked out. And then you'll fill these up based on water damage or gun damage. And then it'll be sunk because these would be would be indicative that it's already in a sinking mode. Okay, let's see here. So the maximum mass okay. So mass, so for example, okay, let's go back. Here it is. So mass 1 is equals to 5 tons, or 0.5 tons, to 250 tons. 250.0 tons. You have on the game system weapon systems displacements, a weight, oh, there's no half tonnage, sorry. They're in 4 tons. Wait a minute. 5, 5, 5, 5, wait, okay, everybody's on a weight here, okay. Three, 5, 3. So it's either 3, 5, or 10. 3, 5, or 0. So anything above, I guess what's actually mass 1 is anything that's 250 tons or less, which would be 3 tons. Well, you can't get a ship for 3 tons, but 3 tons to 250 tons. Mass 2 would equal to 251 tons to 500 tons. And then, so Trafalgar would be actually mass of a mass of 52. And not a mass of 50. Game system mechanics. Every role-playing game, tabletop game system that I've seen, that I've owned, that I got a lot of game systems that are like this, have errors, and when they got unit, when you are able to create a unit, create custom design your own stuff, they have characters, pre-designed characters or vehicles that violate the rules, rule creation for the vehicle or the character. Sometimes that can be represented by the character or vehicle gaining experience points that predate the the player creating a character. Okay, sometimes that is part of the lore within the publication. Sometimes it's not. So yeah, this kind of error, it happens. This is so the Trafalgar is actually 51.72, has a mass of 51.72, which equals to 52, and not 50. Okay, mass 1 is 250 tons. Mass 2 is up to between 251 tons and 500 tons. And the maximum mass is 90. So let's see here, 250. So times 90, 0, 45, 18, 22. That is 200. Okay, so 251 tons to 225,500 tons. This is HMS Dreadnought. (1902–1906) design. Okay, so Space 1889. Space 1889 is significant because in the year 1890, Harvey Steele comes out. And the ship designs for Harvey violate the rules for Harvey Steele warships would not follow this design rules. It completely changes the warship design dynamics. And then in 1900, you had Krupp 1 steel, which is what HMS Dreadnought 1902 was designed with, and that changed the dynamics of warship designs from the pre-dreadnoughts to of the Harvey Steele warship designs. So between 1890 and 1900, the pre-dreadnought, even these were considered great, but this is considered iron and steel, iron and steam era. The Harvey Steele warship designs are considered pre-dreadnoughts. The metallurgy that was in the Harvey Steele warship designs was definitely distinctive from the ironclads. You can do things with the metallurgy of Harvey Steele that you couldn't do with iron. Also, the metallurgy that was done with the Harvey Steele warship designs is not duplicated with the Krupp steel hull warship designs. Actually, this would be, I think, Life Science Library, Life Nature Library. Okay, I grew up on this book. These were published in 1968. A couple of books were published in 1969. So I went through the entire collection, looking at the pictures, before I was in even preschool, before I could even read. I'm 60 years old. I'm cracking this book open. Yeah, I was looking at this book, Man in Space, Flight, and Machines in my high school years. Man in Space, Flight, and Ships is something I still crack open every once in a while. I cracked open when I was in my 50s, which is 10 years ago. So, let's see here. Here we go. Let's see here. I need to put a bandana on so I can keep my glasses on my head. Okay, Age of Sail. This is pre-Mediterranean era. Trafalgar or something like that. The Battle of Lepanto off the coast of Greece. Battle of Lepanto off the coast of Greece. And okay, way back when. Wait a minute. Lepanto was 1571. This is another view of the Lepanto down here. Of what the overall. Excellent series. So, Age of Sail. Age of Sail. Monitor versus Merrimack. think I'm going to just have to do this then. Wait a minute. I'm sipping and sliding. Okay. This is Hood. No, that's Iron Duke. Sister Hood, I think. Battlecruiser. I believe. So yeah, you look at the. This is Krupp steel. Okay, that's not good. I thought they would do a better. So we're going to have to go with this one. Let's see, World War I submarines. Okay, monitors in our 1929. Okay, these are Krupp steel warship designs. Okay. These are our Krupp steel warship designs. This is 1920s. Again, Krupp steel. More Krupp steel. This is Harvey steel. This is a Harvey steel design. In 1900, between 1890 and 1900, Krupp steel. Some nations, some warships were designed with Krupp steel, some were not. This is a Harvey steel design. This is a Harvey steel design. This is a Krupp steel design. This would be a Krupp steel design. Let's see here. Let's get HMS Dreadnought. Aircraft carriers. Now, and so now you get to the 1880s and 1890s. These are Harvey steel designs. This does not have turrets. These do not have turrets. These are turreted. And you have a battery here. As you notice that the battery, okay, above the, you also have guns on the hull. And these are destroyers. Tell by the side, the design layout shows you that These are small ships. And you see it, you can tell that these are actually small ships. Torpedo tubes. And then, simple smokestacks. Not smokestacks, what are these called? Air intakes. And these are smokestacks. And you can tell that these are small vessels just by the shape and structure. Here's a smokestack. This is bigger than, these are torpedo gun boats. So, let's see here, torpedo boats. Passengers liners. Okay, so these are 1884. So paddle wheels. The military did do paddle wheels in the 1850s and 1860s, and I think even in the 1870s. Okay, so now here's the cruisers. Again, Harvey steel technology. Got a lot of these things hanging off the sides that you don't see on Krupp steel warship designs. So there is a distinct, okay, you can tell the difference by how the ships look, what area they are from. They're very distinctive. Glory. Glory. We say glory. Glory is in French, because I think the E is accented in French. Le gloire is how they would pronounce it in France. Yeah, so you got the paddle wheel ships. Let's see here. They say 64, 57, 18. We're talking 1864, 1850, 1839, 1840. So Alabama, 1862. Now these are iron hull ships. These are iron and steel, age of steam, and you can see there is some similarities with the these are USA monitors. Again, low freeboard. Inches instead of feet for freeboard. So Yeah, okay, so let's see here. This guy's 18. So this is pre-Harvey Steel, Corbeil. This is pre-Harvey Steel. This is an iron steamship. These are iron steamships. This is an that could be iron. Although it's definitely in the Harvey Steel era, so that could be Harvey Steel. Again, Harvey Steel is a it's a very small era. Harvey Steel, only 10 years, whereas the steam, iron and steam, lasted a few decades. So 1840s, 1880s. And then Krupp 1 was 1900 to 1910s. And so, which is pre-World War I and World War I. So yeah, there's a lot of difference there. So, mass. So mass 1, okay, for a shallow drought. Get back on sub. So go back here, and that's on. It's up my front. There we go. There we go. So if mass is more than twice its hull size, it is a deep drought ship. Okay. Okay, mass. Okay. Mass is greater than hull size times 2. If mass is more than its hull size, but not twice as much, it is a medium drought ship. So if mass is greater than hull size, and okay, I should actually do. Okay. So the mass is greater than hull size. And if mass is not twice as much as so if mass is less than 2, greater than hull size, but mass is less than hull size times 2, and then shallow draught if its mass is equal to or less than its hull size, that is a shallow draught ship. Less than or equal to hull size. Therefore, hull size, if you look at hull size 1, hull size 1 would be shallow draught. Hull size 4, which is where we're going to be used. Oh, I haven't talked about that yet. I did that in the last video. Okay. So hull size 1 and mass 1 would be a shallow draught. Hull size 1 less than hull size 2, mass is more than twice its hull size. It is twice its hull. It's a deep draught. If mass is more than its hull size, but not twice as much, it means if mass is equal to or less than its hull size. So if mass is equal to twice its hull size, then it is a deep draught ship. Okay, so actually mass 2 can be hull mass 2 could be is either could be described as a medium draft ship. Okay, and then a hull size 3, hull mass 3. So, So a ship that has 250 tons, correction. Okay, so a 50-foot ship that is 250 tons is a shallow ship. A 50-foot ship weighing 500 tons is a medium draught ship. A 50-foot ship, 500. That is 501 tons is a deep draught ship. Okay, above 501 plus tons is a deep draught ship. Now, let's go back. And so the maximum mass is 90, which means the maximum displacement is 22,000 tons. Okay. It's 90. Maximum mass is 90. Maximum displacement is 22,000. Did I do that now? I did the calculations earlier. And yeah, okay, I did the calculations on this video. That's 22,000 tons. Okay. 22,500 tons. Now, so at 90, mass 90, hull size 90, the hull size, of mass, we're going to shorten that now. Mass 90 would have to have a hull size of 90. Hull size 90. Let's go to the, okay. So let's see, 90 times 50 feet is 45 4,500 feet. Okay. For to be a shallow draft. Mass 90 to be a medium draft. Need a size. Less than 90, so 89 or less. All size, okay. Medium draft. Form all draft. All mass. Then we do hull size 89 or less. So that'll be subtract 250, so that's 4,250 tons of feet or less. We do that is minus and let's see here. Mass has to be greater than hull size 2. So hull size okay, maximum is a 400, 200. Let's just reverse this. Okay, anything greater than the hull size. Okay. Mass is 90, so hull size times 2. Okay. Less than hull size times 2. So divide by, okay. $45. Actually, okay. Okay, let's do the mathematical formula here. 90 okay. Mass is greater than hull size. $90 is less than size times 2. Size times 2 is, okay. And that's 50, okay. $25, 22. $2,250 wait, 250 feet. So it's between 2,250 feet and 4,000. Okay, to be a medium draft. Okay. Okay, so yeah. So, and then deep drought. Mass 90. So yeah, there'll be between, okay, so a hull size would be 45 to 89. Deep drop, it has to be 45 or 9. Yeah, mass 90, okay, it's shallow drought for hull 90. 45 to 89 is a medium drought. So hull size 90, hull size 45 to 89 would be medium drought. And then for deep drought, yes, 90 would have to be hull size times 2. So size 45. Yeah, okay, yeah. Anything under than Hull size 1 to 45 to 44. Hull size 1 to 44 would be deep drought. 45 to 89 would be medium drought. And hull size 90 would be 90 drought. Okay. Reversing engineering calculations that I don't normally do. Okay, so let's see here. And we are 1 hour, 6 minutes. Okay. Ironclads in Merrimack. I did this video earlier, so I know where to. I'm going to just go here. Virginia. Is on page. The Virginia Forming Merrimack is on 144, 145. It's up there. It's in italics, so that's graphics. There we are. Oh, and it slipped down again. It matters when I'm doing videos, but it doesn't matter when I'm doing others. I'm not recording. So, Virginia, Monitor, Virginia. Okay, let's look at the data here. The Monitor's on top. They call it Merrimack here, or Virginia. So, okay. Hull proper. Whatever that means. Oh. Hull proper. Is 124 feet in length, 34 feet in beam, and 6.5 feet deep. The drought is, the armor raft is 173 feet in length and 43 feet in wide. Well, 43 and a half or quarter. I think that's half. And then the drought is 10 feet 4 inches. This would be a shallow drought ship because it goes in the river. Yeah, so the difference between, I don't know if I said this in this video or not. The difference between shallow drought, medium drought, and deep drought is, with shallow drought, you can go in rivers. Medium drought, you have shoals you have to deal with. And then deep drought is ocean water. So if you got a deep drought ship and it's traveling in shoals, medium drought shorelines, you're going to have a chance of getting grounded. And then if you're deep drought, if you're in deep drought, you're always going to get grounded. If if you got a medium drought ship and you're in a shallow drought waters, you're going to have chance of grounding. And if you're a shallow drought ship, you're not going to get grounded. Okay. So the monitor, okay, says that the overall length is 73 in the feet, so 173 feet. Yeah, okay, so 50 feet is the hull size. 173 feet is 3. Nope, correction. 150 23.4. That's, yeah, 200. 6. So it's a hull size 4 ship. The monitor. The Merrimack, or the Virginia, has 363 feet. Its length is 363 feet. Beam is 51. Depth is what? Inside? Inside to knuckle? I don't know. "15 feet, casement, battery." Okay, the casement battery is 180 feet long. Gun deck is 160 feet long. Draught is 33 feet. So that's deep draught. Now, so Length 363. $50. 363. 7, 350. That's 13. 130. That's 2. That's 100. 30. That's 7.26. Hull size 8. For the Virginia. Okay, so, but what I'm going to do, okay, since this my version of these two ships for my commuter navy is going to be is not an accurate representation of these two ships. It's not meant to be an accurate representation of both ships, but is a generic design to test out the turret versus the broadside. So what we're going to do, so what I'm going to do, and I did this earlier, I've done this before, about, I was showing another process. Well, before I thought both ships were, I thought this was a hull size 3, and I'm doing, and so I just assumed hull size 3, I just went for it. So this is actually hull size 4. So what I'm going to do, so the Virginia has 1, 2, 3, 4 broadside guns, and 1 gun in the north and bow, and 1 gun in the stern, but it goes out and then comes in, goes in, goes out, goes in and goes out. And same here, out, comes in, out, goes in, goes out. So we're going to have 2 broadsides, and then 1 north and 1 bow and 1 stern. Why am I saying north and south? I'm a Yankee. Okay, no, I don't care about that. We Northerners are, that's ancient history. Move on. So, so both ships are going to be hull size 4, which is maximum of 200 feet in length. And, okay, I dropped the lid in my eyesight. Okay. I'm going to do better on that, but come on. What the? .5 millimeters. Okay, this. This thing's jammed on me. I never had a problem with Pintels. I got 2 broken heads here. Let's see that fixed the problem. Ah, nope. There's no lead in there. Okay. There it goes. Oh, that's 7mm, not 5. Okay. Wait, what? Looks like 0.3. So I got a 0.7 in here, looks like. Although the tip looks like this is a 0.7. That looks like a 0.3 tip. I took drafting classes in high school, 9th grade through 11th grade, 3 years of technical drafting. And we had mechanical pencils for drafting pencils. Okay. And eyesight. And I have 0.7 mechanical pencils, and I have 0.07 and 0.05. And so the 0.07s have, these are the black ones, these are 0.5s, the blue ones are 0.07s. Okay, here's 0.07. More 0.5s. Ooh, rotary cap gun. That's had that forever. I got like 3 different pencil boxes here, drawers. Okay. So okay, these are 0.5s. Maybe they'll work now. What the hell? First time let's see here. Okay, that's okay, it goes in that way. So these are 0.5s. So that works. There we go. It's working. Okay, never had a mechanical failure with Pentel before. And I've been using Pentel pencils since my high school years in the 1980s. So, okay, that's the first. And then this clip. Also, this clip falls off too. Probably have to super glue that. Okay, here we go. Back in business. So, okay, so 250 feet. So that's 4 times 50. There we go. Okay, back in business. So, within the ship design rules, we have hull size 1. It's the gunnery rules. Now you have ship design for naval vessels. Again, I'm slipping and sliding. Okay. You got naval vessel rules. Okay, and then you have aerial vessel design rules. And then you have, now these gun placements were used on naval vessels in this time period. In the 1808, in the Age of Iron and Steel, and in the Harvey Steel era, pre-Dreadnought battleship designs. And then you have your Ether Flyer rules. And then you have the weapons systems that are used in the game. These are the numbers that you need to put it on the ships. And then you have a simplified version over here. No, that's not the simplified. The simplified version is in the back. There. And this is a simplified version of that table. You don't have the ship design, the weights and the costs data. That these tables have. So, no, so on the, oops, yeah, that's, armament rules. I'm going to have to take this thing on here. I said that earlier today. Let's see here. Select one or more weapons from the table below. Okay, turret guns are mounted on large rotating masses. Range of 3 patterns, centerline guns. Ship has 2 midship turrets. FM forward turret and AM aft turret. Offset turrets are placed on the right sides. You can have port side turret and starboard turret. You can have corner turrets, port forward, port aft, stern forward, stern aft, although they said whatever. May be built both with centerline and offset turrets, or centerline and corner turrets, or corner turrets and offset turrets. Ship may not be built with all 3 types. So ships which combine centerline turrets with another type may not have a midship turret. So you can say centerline turret, corner turret, offset turret. So you can say I want to have a midship turret, 2 midship turrets, okay, 2 centerline turrets, and then 2 centerline midship turrets. Or you can have corner turrets. You can say centerline turret and corner turrets, centerline turrets and offset turrets. But you cannot have centerline because, well, corner turrets would be here, and offset turrets would be more or less over here. So you can't say I want to have center turret, corner turrets, and then offset turrets. And you go over here. That's basically what's going on here. You have corner turrets, center turret, and corner turrets. One more. So, in addition to turrets, the ship may have a number of battery guns. Battery guns are mounted along the side of the ship. These are battery guns. Subtract the total number of turrets installed on the ship from the hull size. So we're playing with hull size 4. You subtract turrets. So 0 turrets. That's the total, subtract the total number of turrets installed on the ship. So 4 subtract 0 is 4. Multiply that by 2. This is the total number of battery guns which may be installed per side. So hull size 4. You can have up to 8 guns per side. So that means, but what I've decided to do is, anyway. I'm going to do this arrangement. So you have 2 4 sides. Okay, so you can go 4 6. This is to be wing. You can have wing sponsons here. But I get ahead of myself there. Okay. Some ships may include armored battery enclosures only that only closes part of the ship. That's the battery structures of that would be this. 1900. That would be a battery right here on the Boston. These would be batteries. Okay. Actually, that, so it'd be better. That would be an army battery on the Vanguard. These would be batteries. The gun decks would be considered an armored battery. But that's not what I'm looking for. That's the red knot again. Nope. Der Flinger. There's the dreadnought. Carriers, we're going past that. Okay. Battleships. Okay, yeah. This would be this is the battery. That would be a battery right there. That would be an armored battery. That would be an armored battery. So the armored battery could be part of a main deck, gun deck, or it'd be, which is, the gun deck is the upper deck on the hull. Under the main, deck. The armored deck is at the waterline. Okay, this submarines. Let's go back here. Okay, yeah. So this is the battery. This is 1896. The armored deck. Okay, okay. Here you go. This canopus. This is best. That's the armored battery on the deck, but the gun deck here could also be considered a battery. But the armored deck, the deck armor, correction, is at the waterline. Although on some ships, on the older ships, there would be actually the deck itself. On the iron steel hulls, there'd be, but on the 1880s, 1890s, they actually did the armored deck was at the waterline. So that's so yeah, when you're talking about the battery, you're on the 1880s, you're usually talking about this up here, and not the interior structure of the ship. Basically, there you are. So your armored deck, this is the, I should do. Okay, that's the water. Okay, so the wave is the water action, and the armor deck is at the waterline of the ship. And but the back in the old 1860s, 1840s, whatever, the armor deck would actually be this structure here, and then you had your gun decks here. But you also had your building here with your guns here. And then you had your turret. So, and then with battery, with all or nothing strategy, your battery is actually, you have your machines here, engine, and you got your shaft, and you got your propellers. Okay, and so your armored battery, and then you had your ammo and stuff. Here, this is the barbette. This would be the barbette where your ammo and was stored. So you would have your battery would be okay, your turret here, turret here, we're going to so these guns would be this stuff here, and these guns would be this stuff here. And then, so your battery would be, your citadel, actually, would be like that. And then your bulkhead, this would be your bulkhead of the citadel, and this would be the battery of the citadel. Okay. With the, okay, that's the all or nothing theory ship design. And then the deck armor, okay, so you're actually, the citadel would actually be up here. So your deck armor, your citadel deck armor would be this, and then here's your bulkhead down there like that. So, but with that, with this is basically, the battery could be this, and the battery could be that, battery could be this, and the battery could be that, and then this would be your bulkhead. You could have a bulkhead armor structure here also to protect the guns on the deck. Okay, so this would be your bulkhead, and this would be your bulkhead. So yeah, and then again, bulkhead, for the top structure. So there's some variations in that design process. Okay. I was looking for my other paperwork. That's blank. There's my other paperwork. So, let's see here. So, what we're going to do represent to identify to acknowledge what's going on here. Hull size 1, hull size 2, hull size 3, hull size 4. So we're going to I can do better than that. Okay, so we're going to have the turret for the monitor. Monitor example. And then for the Virginia model, we're going to have this. Actually, so the gun here, gun there. These are the gun positions. You're going to have a gun here, a gun there, and then gun there. And then this turret can rotate in all 4 directions. And the turret is going to have 2 guns in it. It's going to be a twin turret design. So instead of actually looking like that, I just did those extras to show that what angle it is. The turret is actually going to look like this. Yeah, the turret is going to have 2 guns, and then the guns will be able to rotate. Okay, so that's what I'm working on. That's the design theory I'm playing with. Okay, this is scrap. So, one other dilly-dally. Take into consideration is mass of the ships. Okay. So a hull size 4. Okay, let's do this. Size 4. A shallow draft would be mass 4 or less. So it'll be, okay, so 250 is 1,000 tons or less for shuttle. 250 for the maximum. Okay, mass is less than hull size 2, hull size times 2. So hull size times 2 is 8. 0, 40, 16, 2,000. $250 is greater than hull size 4. So it's going to be 1,001 tons to 2,000 tons. So hull size 4 would be Also, mass, yeah, 8. So, which is, mass 4 is 1001. And 2,000 tons. So it's under 2,000 tons and between 1,000 and 2,000 tons. Hull size 2, anything greater than the hull size 2. Mass, correction, size 4. So a mass would be 9 or higher. So that is 2,000, which is basically 2001 plus. Oh, there you are. So, we're looking at a ship hull size 4, that's times 50, that's 1,000 tons. So the Monitor would be 1,000 tons. The Merrimack would be deep drought, 2001 plus. Let's see here. One other thing I'm going to deal with, and that's 2 hours. Okay. One other thing I'm going to talk about on mass and hull size. Okay. Yeah, that's right. Units of measure. Hull size and hull mass. Now within, so the game system has a maximum mass of 90. Okay, so how big of a ship can you make? Now, what is realistic? Okay, the most warships of this time period had a maximum hull size of 8, around 400 feet. Okay, historically, okay, historic hull size maxed out at around 8. The hull, so that would be for units of measure. For calculation purposes. Okay. Hull size 8 divided by mass of 90 would give you a ratio. Wait. Yeah. Of 11. Ratio of 11.5, 11.25. I went through the lists, the ships of the nations, representing all of the naval vessels and the aerial flyers and the ether flyers. The aerial vessels and ether flyers are fictional, but some of these warship designs, or these are based on real life warship designs, calculations. The suit are correct, but they may be incorrect. I'm not going to go there. YouTuber Dracula would probably go there. So what I found is that the maximum ratio for hull size to mass is 8 plus 7. So for hull size 1, go over here. So for size 1, you would have mass of 8 plus 1, or plus 7. So, but actually that's not correct. That would be hull size. For example, it would be more like actually for hull size, be like hull size 2, hull size 1 and up. So it'd be for you'd have hull size 2 with the 8 plus. It'd be your mass would be your tonnage displacement would be 16. Wait. Your mass would be 16 times 250. No. Maybe 8, okay. Yeah, no, it'll be actually mass of 16 plus 7, which equals to 23. Okay, or size 6. Actually, these masses would be in the size 6 range. So mass 8.1 would be 48 plus 7, which equals to 56. Okay, that's 3. Okay, so that's okay. So that's the ratio of 8 plus 7 per, okay. Okay, mass 8 plus 7 per size. And these would, and this mass ratio would actually apply to hull sizes around hull size 6 and hull size 8. It would be size 6 and size 8. Okay. Okay, ratio theory number 1. Okay, ratio theory number 2 I use is based on these naval ship forms. 1, 2, 3, 4, 5. So ratio is mass 5 per size. So, therefore, mass 90. Therefore, if you have a mass 90 ship, divided by 5, we have hull size 18. Hull size 18 times 50. Reverse that to simplify the math. Zero, 49. 900 feet in length. Yes, that would be 900 feet in length because hull size 8, okay, 50 times 8, 0 is 400 feet in length. So, hull size 90 divided by, so if you want to also go theory number 1, 8 divided by 90, x, oh, that's where the number is. That's a whole, okay. That's 1, that's 8, 1, that'll be a hull size 12, equals, let's get rid of that. Okay, you're 11, so 11, okay, that's, size 12. And size 12 is, okay, 12 times 50, 0, 10, that's 600 feet. So, and that's that for this video.